On the open grasslands of East Africa, a Thompson's gazelle freezes for a fraction of a second. The wind shifts, carrying the faint scent of a cheetah hidden in the tall grass. Around it, the herd tightens. No noise, no panic, only a sudden wave of alertness. The gazelle lowers its head, then springs straight upward in a series of high bounds across the plain. It is not running away yet. It is signaling. Will this display of strength be enough to discourage the fastest land predator on Earth? Or will the stalk continue? This documentary explores how animals survive in landscapes where predators are constantly present. Every behavior shown here is based on real observations from wildlife biologists, field researchers, and long-term ecological studies. No scenes are exaggerated or invented. We will look at how prey species reduce risk, how predators shape the behavior of entire ecosystems, and how survival often depends not on strength, but on awareness, adaptation, and timing. Understanding these interactions matters because predator-prey relationships regulate populations, maintain biodiversity, and keep natural systems functioning. Today, we follow real examples from savannas, oceans, forests, and deserts, focusing on one central question: how do animals live alongside predators every single day? This documentary is presented for educational and informational purposes only. All content is based on real-world animal behavior, supported by scientific research, ecological studies, and verified observations from reputable wildlife organizations and natural history sources. No information is fabricated, fictionalized, or exaggerated. Before we continue, please like, share, comment, and subscribe to support the channel and help us bring more nature stories to life. The dry season settles across the Serengeti. Grass grows short, and visibility stretches for kilometers. For grazing animals, this openness is both safety and exposure. Plain zebras, wildebeest, and gazelles gather in mixed herds, not by accident, but as an evolved form of protection. In the center of the herd, younger animals stay close to experienced adults. Along the edges, the most vigilant individuals raise their heads often. Studies have shown that in large groups, individual animals spend less time watching and more time feeding, a benefit known as the many eyes effect. One animal sees movement, another hears a rustle. Together, detection happens sooner. A lioness crouches more than 100 meters away, using patches of remaining grass for cover. She does not rush. Instead, she waits for a small mistake, spacing that opens a gap, or an animal that lingers just a little too long. The herd forms subtle lines, angling toward a shallow depression in the land, terrain that offers better visibility. The zebras turn their striped flanks toward the lion's direction. Their patterning does not make them invisible, but it can make it harder for a predator to isolate a single target when the herd moves at once. The lioness advances 2 paces, then stops again. An impala gives a sharp snort. Heads lift. The quiet tension breaks into coordinated movement, not chaos. The herd does not sprint. It simply widens the distance and removes the opportunity for an ambush. Water is still several kilometers away, and dry conditions mean fewer safe paths to reach it. To feed and drink, these animals must cross open spaces again. The question remains, can vigilance and group coordination continue to offset the advantage of stealth, especially as the dry season deepens? The herd begins the slow journey toward the remaining water sources, where other predators may also be waiting. In tropical and temperate forests, survival looks very different from the open plains. Here, visibility closes in. Light is filtered through layers of leaves, and sound carries in unpredictable ways. Instead of speed across distance, survival often depends on remaining unnoticed. A young gray tree frog clings to mottled bark. Its skin shifts in shade over several hours, aligning with the lichen-patterned trunk. This is not conscious disguise. It is physiology responding to light, temperature, and background contrast. Nearby, a praying mantis holds perfectly still, its body shaped like the leaves it waits among. Both animals rely on the same principle. If predators cannot easily detect them, they do not need to flee. On the forest floor, a herd of red deer moves slowly between feeding patches. Their calves stay close to dense cover. When they are very young, many deer species use stillness as a primary defense. Their spotted coats break up their outline, scattering light across the pattern. Predators in forests, such as lynx or wolves in some regions, depend on detecting shape and movement among vegetation. Remaining motionless can be as effective as running. Higher in the canopy, birds add another layer of strategy. Mixed species flocks, tanagers, warblers, and tits in some woodlands travel together through the trees. Each species focuses on different insects and different layers of foliage, reducing competition while increasing vigilance. When one bird gives an alarm call, others respond instantly, even if they are unrelated species. Over time, researchers have learned that these calls carry specific information about type of threat and direction, helping animals adjust their behavior within seconds. A leopard in an Asian forest moves along a shaded path at dusk. Unlike cheetahs of open savannas, leopards rely primarily on ambush within cover. Their success depends on getting extremely close before revealing themselves. This single fact shapes the behavior of many forest animals. Short, sudden movements to nearby cover, rather than long-distance sprinting, are often the safest escape response here. The environment is changing, though. Seasonal leaf fall reduces hiding places. Streams shrink into smaller pools where many species must come to drink, concentrating activity into predictable locations. With fewer options for concealment, animals that normally evade detection may now be more visible. As night approaches and visibility shifts again, a new challenge emerges. How do animals adapted for camouflage and stillness respond when darkness favors the senses of nocturnal predators such as owls or civets? In the ocean, there are no trees to hide behind and no tall grass to break a silhouette. Survival relies on movement, depth, and collective behavior. The water column is a three-dimensional world, and threats can approach from any direction. A school of sardines forms a shifting sphere just beneath the surface. Each fish keeps a precise distance from its neighbors, guided by simple rules of spacing and alignment. No single leader directs the motion. Coordination emerges naturally as individuals respond to those closest to them. This tight formation reduces the chance that any one fish will be singled out, a well-documented effect known as safety in numbers. Nearby, common dolphins patrol the same waters, not randomly but along productive currents where cold, nutrient-rich upwellings support dense plankton and, in turn, the small fish that feed on it. These predators do not simply chase the nearest prey. They work cooperatively, guiding schools toward compact shapes that make feeding more efficient. Seabirds overhead queue into the same events, watching for disturbances at the surface. Multiple species respond to the same concentration of life, each occupying its own ecological role. Individual sardines within the school face constant choices shaped by instinct. Maintain alignment, match speed, avoid collisions. When a fast-moving shape approaches, the school ripples, splitting and rejoining in fractions of a second. This coordinated movement can make it difficult for a predator to track a single target through the shifting mass. Unlike animals on land, escape here can mean moving upward, downward, or laterally, and depth changes are often the fastest option. Far below, light fades and temperature drops. Some species, such as lanternfish, avoid surface waters during the day and ascend only at night to feed. This daily vertical migration, the largest coordinated movement of animals on Earth, reduces daytime exposure in brighter, more visible layers of water. Predators respond as well, timing their activity to these rhythms. Survival becomes a matter of being in the right layer of the ocean at the right time. Environmental conditions add another layer of complexity. Changing currents alter where plankton blooms form. When food shifts, fish schools must travel longer distances, crossing areas with fewer hiding opportunities. Marine mammals and large fish adjust their routes too, following productivity rather than place. As dawn approaches after a night of feeding and movement, the sardine school begins to descend again, toward darker water where visibility is limited. But along the thermocline, the sharp boundary between warm and cool layers, new silhouettes appear on the edge of perception. Will the school find safety in deeper, dimmer water, or will the sudden gathering of multiple species reshape the next hours of their journey? In the world's hot deserts, survival is shaped less by concealment and more by timing. Daytime temperatures can soar, and predators and prey adjust their lives around cycles of heat and darkness. Many species avoid the hottest hours entirely, becoming most active at dusk, night, and early morning. On a sandy plain in the American Southwest, a Merriam's kangaroo rat emerges from its burrow. It moves in quick, bounding hops, pausing often to listen. Its large ears are finely tuned to low sounds. Tiny grains of sand displaced by movement can be enough to signal risk. Above the desert floor, a great horned owl patrols silently. Unlike diurnal raptors, owls rely on exceptional hearing and near-silent flight, allowing them to detect faint rustling below. The kangaroo rat uses more than speed. It forages close to the entrances of multiple shallow burrows, a network of escape routes dug over time. When startled, it can leap sideways and change direction rapidly, a behavior that reduces capture risk. Research has shown that these rodents also adjust activity according to moonlight. On bright nights, when they are easier to see, they spend less time in open spaces and more time near cover. Elsewhere across North African deserts, a fennec fox begins its nightly search for insects and small vertebrates. Its oversized ears are cooling surfaces and also sensitive detectors of underground movement. Unlike large plains predators, desert hunters often rely on pinpoint accuracy at very short distances. Burrowing animals respond in turn by sealing entrances and using deep tunnels where temperatures and scents are more stable. Reptiles add another strategy. Sidewinder rattlesnakes move in distinctive S-shaped tracks, lifting parts of their bodies off the hot sand to reduce heat absorption. They often wait partially buried, detecting vibrations and heat signatures rather than actively roaming in daytime heat. Small lizards and rodents that share these landscapes learn to reduce time spent in exposed areas, moving in short bursts from shrub to shrub. Seasonal change reshapes the rules. After rare desert rains, plants bloom quickly and insects emerge in large numbers. This brief abundance draws many species above ground at once, and with increased activity comes increased encounters between predators and prey. For a few weeks, the desert becomes a patchwork of opportunity and risk. As the night cools further, the kangaroo rat gathers seeds in its cheek pouches and pauses at the edge of open ground. The owl is no longer visible, but the possibility of its presence remains part of every decision the small mammal makes. How far to travel, how long to forage, when to retreat. Dawn is approaching. Temperatures will rise, and diurnal predators will begin their day as nocturnal hunters rest. How will animals that depend on darkness adjust their behavior as light returns? And which species will take their place in the shifting rhythm of the desert? In polar and subpolar regions, survival is governed by extremes of light and ice. For many animals, the greatest challenge is not constant pursuit, but rapid seasonal change that reshapes where predators and prey can travel, hunt, and feed. Along the Arctic sea ice, a ringed seal surfaces at a narrow breathing hole. Beneath the ice, it has carved a network of air access points, maintained by constant scraping with its claws. These openings are essential. Without them, the seal cannot rest or reach the surface to breathe. Above the ice, conditions appear empty, but the open platform connects vast hunting ranges for larger predators. The seal is alert not because of noise, but because of absence. Snow cover dampens sound, and wide horizons reveal little movement. Survival here depends on habit and awareness of structure in the ice. Thick ridges, pressure cracks, and snow drifts can conceal both prey and predators, and many Arctic species learn to read these subtle features as part of daily life. A polar bear moves slowly across the broken floes. Unlike fast-chasing hunters of the savanna, this species relies on patience and proximity, often waiting for long periods near active breathing holes. Its success depends on timing its movements with the seasonal presence of sea ice, where seals are accessible. When ice retreats earlier in the year, bears must travel farther or turn to alternate food sources on land, changing the rhythm of their year. Farther south in the subarctic, a different dynamic plays out on the tundra. In summer, plant growth surges, insects emerge in vast numbers, and migratory birds arrive to nest. Arctic foxes track these seasonal pulses closely, shifting from scavenging marine leftovers in winter to hunting small rodents such as lemmings when the ground thaws. Lemming populations naturally rise and fall in multi-year cycles, and predator breeding success often follows these cycles in turn. Caribou herds add motion to this landscape. They migrate hundreds of kilometers between wintering forests and summer calving grounds on windswept tundra. Open, breezy areas help reduce insects and increase visibility, giving calves a better chance to avoid ambush by wolves or bears. Yet the journey itself carries risk: rivers to cross, weather to outlast, and predators that follow the herds over long distances. As autumn approaches, daylight shortens rapidly. Ice begins to reform along coastlines and lakes. Movement corridors close, and animals must again adjust to a world that hardens beneath them. For seals, new ice brings protection from some predators, but limits access to open water. For bears and Arctic foxes, the expanding ice reopens travel routes, but requires renewed searching for scattered prey. The first full freeze of the season spreads overnight across a wide bay. Breathing holes contract, migration paths shift, and hunting strategies must change with the ice itself. Which species will benefit from the returning frozen platform, and which will be forced to alter long-established patterns as the season locks into place? Freshwater ecosystems create narrow corridors of life through otherwise dry or forested landscapes. Rivers, lakes, and wetlands concentrate animals around the same essential resource: water. This concentration brings opportunity, but it also increases encounters between predators and prey. Along a broad African riverbank, a herd of elephants approaches cautiously. They are among the largest land animals, yet they still adjust their behavior near water. River edges can be unstable, and steep access points limit escape routes. Crocodiles wait submerged, relying on stillness and the element of surprise. These reptiles are not constantly attacking. Instead, they conserve energy, responding only when animals enter the small zone they can effectively reach. Antelope and zebra approach the water in short visits, drinking and lifting their heads frequently. Many species choose crossing points with gradual slopes and wide views. Others wait until midday, when some predators are less active. Decisions like these, where to drink, when to cross, are shaped by learning and by observing the responses of other herd members. Further upstream in North America, salmon return from the ocean to the rivers of their birth. Their journey is driven by powerful biological timing rather than moment-to-moment decision-making. As they move upstream, bears position themselves at narrow passages and waterfalls, places where fish must pass through confined channels. The fish are not chosen as individuals. Instead, the predictable flow of migration supports both predator and prey populations. Nutrients from salmon carcasses later fertilize forests and feed birds, insects, and mammals, linking river life with surrounding ecosystems. In floodplain wetlands, the situation reverses with the seasons. After heavy rains, water spreads out across wide areas, creating temporary lakes and channels. Fish disperse into new habitats rich with vegetation and insect life. Predators must adapt to this expanded landscape, shifting from ambush near single channels to wider searches across flooded grasslands. As waters recede, fish and amphibians concentrate again into shrinking pools, increasing encounters with wading birds and aquatic hunters. Amphibians face a different challenge. Frogs and toads often breed in exposed water, where eggs and tadpoles are vulnerable. Their survival depends on numbers and timing rather than individual defense, laying large quantities of eggs during brief windows when conditions are favorable. Many predators feed on a portion of these young, yet enough typically survive to sustain populations year after year. As dry season approaches once more, river levels fall. Crossing points become fewer, shorelines harden, and access to water narrows into specific locations used by many species at once. Activity increases around these shrinking resources, and strategies shift accordingly. Shorter visits, greater vigilance, and in some cases, long-distance travel to new water sources. The river continues its slow, seasonal transformation. Channels deepen, pools contract, and migration routes reappear or disappear with changing flow. How will the animals that depend on this moving ribbon of water adjust as the landscape around it changes yet again? Around the world, many animals now live in landscapes shaped by people. Urban parks, farmland edges, and suburbs create a mosaic of buildings, roads, and small fragments of natural habitat. Predators and prey do not disappear here. Instead, they adapt in ways scientists are only beginning to fully document. In North American cities, raccoons navigate storm drains and green spaces at night. Their flexible diets allow them to use both natural foods and human leftovers, but their behavior remains strongly influenced by risk. They often travel along edges, fences, tree lines, and walls, avoiding open spaces where movement is more visible. Coyotes, once associated mainly with prairies and deserts, now occupy many metropolitan areas as well. GPS tracking has revealed that urban coyotes often shift activity into nighttime hours, reducing encounters with people while still hunting rodents and rabbits. Pigeons and songbirds alter their strategies too. Artificial light extends feeding hours for some species, while others move to quieter patches during rush hour noise. Predation pressure remains real. Urban hawks such as Cooper's hawks and peregrine falcons use tall buildings as nesting cliffs and hunt along open corridors created by streets and rivers. Their presence influences where flocks gather and how often they take flight. On another continent, red foxes in European cities show similar patterns. They raise young in dens beneath sheds or in overgrown lots, and they frequently use predictable paths through gardens and alleys. Studies have shown that these foxes become more nocturnal than rural populations, illustrating how activity patterns shift in response to disturbance and opportunity. Small mammals respond in kind, concentrating in vegetated patches that provide cover from both aerial and ground predators. Urban environments also create refuge species, animals that benefit from reduced numbers of large predators. White-tailed deer in some suburban areas reach high densities due to abundant ornamental plants and limited hunting or predation. This, in turn, affects vegetation, leading to changes in forest regeneration and understory structure. Even in human-dominated settings, predator-prey dynamics continue to shape ecosystems. Water channels through cities tell another version of the story. Otters return to cleaner rivers in parts of Europe and North America, following fish populations into urban centers. Their presence signals improving water quality but also restores an ancient interaction between aquatic predators and prey in modern settings. Fish respond by using submerged structures, shaded bridges, and deeper pools as shelter. Yet urban adaptation brings new challenges. Roads fragment habitat, and artificial barriers change movement routes. Animals must navigate traffic noise, light pollution, and human presence, all of which influence when and where they travel. Some species develop smaller home ranges with high resource availability. Others must cross wide developed areas to reach seasonal needs. As night deepens over the city, lights flicker in windows while movement increases in parks and along riverbanks. A coyote pauses at the edge of a golf course, listening. A falcon settles onto a high ledge, waiting for dawn. Urban nature continues quietly alongside human life. With habitats around the world shifting faster than many species experienced in the past, an open question remains. How will wildlife continue adjusting to environments shaped so strongly by people, and which species will thrive or decline as these new ecosystems evolve? Not all animals rely on speed, concealment, or long-distance escape. Across many habitats, some species survive by being difficult, costly, or risky for predators to attack. These defenses are not absolute shields. They are tools that shift the balance between effort and reward. On the African savanna, a porcupine moves deliberately through low shrubs. Its quills are modified hairs stiffened with keratin, loosely attached, so they detach when pressed. Contrary to popular myths, they are not projected through the air. Instead, the porcupine presents its back and rattles specialized hollow quills as a clear warning. Many predators learn from brief, non-fatal encounters to avoid attempting to grasp such heavily defended prey again. The result is behavioral change across a community based on experience. Elsewhere, in North American woodlands, a striped skunk forages at dusk. Its bold black and white pattern functions as an honest signal, known scientifically as aposematism, a warning coloration that advertises strong chemical defenses. When threatened, the skunk stamps its feet and arches its tail before releasing its spray. Most predators recognize these displays early and disengage, conserving energy for less costly opportunities. In tropical rainforests, bright hues on some frogs convey a similar message. Poison dart frogs do not use their toxins aggressively. Instead, their skin contains compounds derived in part from their natural diet of ants and mites. These chemicals make them unpalatable to many predators. Nearby, harmless species sometimes mimic the same patterns and colors, gaining protection through resemblance, an evolutionary pattern known as Batesian mimicry. In the oceans, pufferfish represent another approach. When threatened, they can inflate by taking in water or air, increasing their size and making themselves more difficult to swallow. Many species also contain tetrodotoxin, a potent natural compound found primarily in their organs and skin. Predators that sample such prey often avoid similar shapes in the future, reinforcing the survival value of recognition and learning. Armored defenses appear in insects as well. The monarch butterfly caterpillar feeds on milkweed plants that contain cardiac glycosides. These compounds accumulate in the caterpillar's tissues and remain in the adult butterfly, making it distasteful to many birds. The monarch's orange and black wings signal this fact clearly in flight. Over time, predators learn to associate the colors with an unpleasant experience and focus on less well-defended prey. Even plants shape predator-prey interactions by influencing defenses. Some acacias grow thorns and produce chemicals in response to browsing. Herbivores adapt by rotating feeding locations or selecting plant parts with lower defenses. These subtle exchanges influence entire landscapes, determining which species dominate and which retreat. Defenses come with trade-offs. Producing toxins, heavy armor, or large quills requires energy. Highly visible warning colors may attract attention before the lesson is learned. Animals that invest in strong defenses often move more slowly or rely on smaller territories, while those without such defenses may emphasize speed or vigilance instead. Evolution distributes strategies rather than declaring a single winner. As evening falls over savanna, forest, and reef alike, the pattern repeats. Some animals remain hidden, others move quickly, and some simply signal, "Not worth the attempt." But defenses are never perfect, and environments continue to change. As new predators expand their ranges and climates alter habitats, will today's successful defenses remain effective, or will different strategies rise in importance in the next chapter of life on Earth? Across ecosystems, survival is not only about physical traits. It is also about information, what animals learn from experience, and how that learning shapes future behavior. Predators and prey continually adjust, not through planning in a human sense, but through repeated interactions that influence instincts and responses over time. On the African plains, young elephants watch older herd members closely. When the matriarch alters course at the scent of lions, or when she chooses a safer river crossing, the younger animals follow. Over years, they build a mental map of food sources, migration routes, and locations associated with risk. Research has shown that elephant family groups with experienced leaders often navigate hazards more effectively, especially during droughts. In coastal waters, young sea otters spend months riding on their mother's chests as she dives and returns with food. During this period, pups observe which prey to target, how to use stones to open shells, and where to forage while avoiding larger marine predators. Behavioral traditions like these can persist within populations, forming what biologists call cultural transmission, learning passed not genetically, but socially. Small songbirds demonstrate learning in a different way. When a hawk appears near a feeding station, birds scatter toward dense shrubs. Over time, individuals choose perches that allow rapid escape and feed in shorter bouts when danger is more common. Those that recognize alarm calls quickly gain an advantage in reaction time. Predators adjust too. Hawks may alter approach angles or choose perches that provide better concealment before flight. Even reptiles, often assumed to be simple in behavior, show forms of learning. Studies of lizards and turtles reveal that many individuals remember safe basking sites and reliable shelters and return to them repeatedly. After non-lethal encounters with predators, they may shift activity to cooler hours or thicker cover, reducing future exposure. On the savanna, a cheetah finishes a brief pursuit without success. Energy has been spent, and the prey escaped. Future hunts may begin with longer stalks and shorter chases, reflecting the delicate balance between effort and probability. Prey animals that were targeted now respond more quickly to similar approaches, tightening herd spacing or choosing different grazing areas. No event stands alone. Each one slightly reshapes the next. Environmental change adds another layer to this process. As temperatures, vegetation patterns, and water availability shift, animals encounter new combinations of risk and opportunity. Some species alter migration timing, others expand or contract their ranges. Young animals growing up in altered conditions develop behaviors suited to the environments they experience, a process known as behavioral plasticity. Across forests, oceans, deserts, rivers, and cities, one theme connects these stories. Survival is dynamic. It is the result of inherited traits interacting with changing conditions and accumulated experience. Every chase avoided, every shelter found, and every route remembered becomes part of a larger pattern of adaptation that continues across generations. As daylight fades on another cycle in the natural world, animals settle, forage, or move, not in search of drama, but simply in response to the environments that shape them. The question remains open for every species. How will tomorrow's conditions, predators, and opportunities reshape the next decisions they make? Across all these chapters, one pattern emerges with clarity. Survival is not a single dramatic moment, but an ongoing relationship between predators, prey, and the environments they share. Every landscape, plains, forests, oceans, deserts, rivers, ice, and cities, creates its own rules. Animals respond through vigilance, cooperation, camouflage, timing, defenses, and learning. None of these strategies guarantees safety. Instead, they increase the likelihood of living long enough to feed, migrate, and raise the next generation. Predators are not villains, and prey are not merely victims. Each plays an essential ecological role. Predators help regulate populations, preventing overgrazing and maintaining healthier herds. Prey species shape plant communities, seed dispersal, and nutrient cycles. Together, their interactions support the biodiversity that keeps ecosystems stable and resilient. As environments change, through climate shifts, habitat loss, and human influence, these relationships continue to evolve. Some species adapt quickly, others face greater challenges. Observing these changes with careful science allows us to understand how life persists and what actions can support functioning ecosystems into the future. The story of surviving deadly predators is ultimately the story of balance, constant adjustment, quiet resilience, and the remarkable capacity of living organisms to fit their surroundings. If you enjoyed this journey into the wild, subscribe for more real animal stories. Leave a comment below. What part surprised you most?